Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos.
Lesson 1. Matter in our surroundings. As we look at our surroundings, we see a large variety of things with different shapes, sizes and textures. Everything in this universe is made up of material which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or a particle of sand, everything is matter. Physical nature of matter. Matter is made up of particles. When we dissolve salt in water, the particles of salt get into the spaces between particles of water. How small are these particles of matter? There must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. Estimating how small are the particles of matter. With every dilution, though the color becomes light, it is still visible. The particles of matter are very small. They are small beyond our imagination. Characteristics of particles of matter. Particles of matter have space between them. Similarly, when we make tea, coffee or lemonade, nimbu pani, particles of one type of matter get into the spaces between particles of the other. This shows that there is enough space between particles of matter. Particles of matter are continuously moving. Particles of matter are continuously moving, that is, they possess what we call the kinetic energy. As the temperature rises, particles move faster. So, we can say that with increase in temperature, the kinetic energy of the particles also increases. Particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion. We also observe that on heating, diffusion becomes faster. Particles of matter attract each other. Particles of matter have force acting between them. This force keeps the particles together. The strength of this force of attraction varies from one kind of matter to another. States of matter. We can see that matter around us exists in three different states: solid, liquid and gas. These states of matter arise due to the variation in the characteristics of the particles of matter. Now, let us study about the properties of these three states of matter in detail. The solid state. Solids have a definite shape, distinct boundaries and fixed volumes, that is, have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid. The liquid state. Liquids have no fixed shape, but have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but can be called fluid. Solids and liquids can diffuse into liquids. The gases from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. All living creatures need to breathe for survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Thus, we may conclude that solids, liquids and gases can diffuse into liquids. The rate of diffusion of liquids is higher than that of solids. This is due to the fact that in the liquid state, particles move freely and have greater space between each other as compared to particles in the solid state. The gaseous state. We come to know of what is being cooked in the kitchen without even entering there, by the smell that reaches our nostrils. The particles of the aroma of food mixed with the particles of air spread from the kitchen reach us and even farther away. The smell of hot cooked food reaches us in seconds. Due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. In the gaseous state, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the walls of the container. Gases are highly compressible as compared to solids and liquids. The liquefied petroleum gas, LPG cylinder that we get in our home for cooking, or the oxygen supplied to hospitals in cylinders is compressed gas. Compressed natural gas, CNG, is used as fuel these days in vehicles. Due to its high compressibility, large volumes of a gas can be compressed into a small cylinder and transported easily. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. Can matter change its state? We all know from our observation that water can exist in 3 states of matter: solid as ice, liquid as the familiar water, and gas as water vapor. Effect of change of temperature. On increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed positions and start moving more freely. A stage is reached when the solid melts and is converted to a liquid. The temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of a solid is an indication of the strength of the force of attraction between its particles. The melting point of ice is 273.16 K. The process of melting, that is, change of solid state into liquid state, is also known as fusion. The temperature of the system does not change after the melting point is reached till all the ice melts. This happens even though we continue to heat the beaker, that is, we continue to supply heat. This heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature. When we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. Boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 373 K, 100 degree C, equal to 273 plus 100, equal to 373 K. Particles in steam, that is, water vapor at 373 K, 100 degree C, have more energy than water at the same temperature. This is because particles in steam have absorbed extra energy in the form of latent heat of vaporization. So, we infer that the state of matter can be changed into another state by changing the temperature. Substances around us change state from solid to liquid and from liquid to gas on application of heat. But there are some that change directly from solid state to gaseous state and vice versa without changing into the liquid state. A change of state directly from solid to gas without changing into liquid state or vice versa is called sublimation. Effect of change of pressure. We have already learned that the difference in various states of matter is due to the difference in the distances between the constituent particles. Applying pressure and reducing temperature can liquefy gases. Solid carbon dioxide, CO2, stored under high pressure. Solid CO2 gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid, or gas. Evaporation. Water, when left uncovered, slowly changes into vapor. Wet clothes dry up. We know that particles of matter are always moving and are never at rest. At a given temperature in any gas, liquid, or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into vapor. This phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Factors affecting evaporation. An increase of surface area. Evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out. An increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. A decrease in humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. An increase in wind speed. It is a common observation that clothes dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. How does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings makes the surroundings cold. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Why should we wear cotton clothes in summer? During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during evaporation, the particles at the surface of the liquid gain energy from the surroundings or body surface and change into vapor. The heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. Why do we see water droplets on the outer surface of a glass containing ice-cold water? Let us take some ice-cold water in a tumbler. Soon we will see water droplets on the outer surface of the tumbler. The water vapor present in air, on coming in contact with the cold glass of water, loses energy and gets converted to liquid state, which we see as water droplets.